Recording in progress.
Hello dear students, this is your Engineering Mathematics 3 lecture. Today's topic is Poisson distribution. This topic is from 4th unit, Probability and Probability Distributions. In previous lecture, we have discussed binomial distribution. Now, Poisson distribution. What is Poisson distribution? When P be the probability of success and it is very small, and the number of trials n, small n, is very large, and n into p, this product is finite, then the distribution is called Poisson distribution. See, what is the condition for Poisson distribution? Poisson distribution means Poisson probability, it is a probability distribution. When p, the probability of success is a very small value and the number of trials n, this value is very large, and the product n into p is finite, then the distribution is called Poisson distribution. The probability of R successes in a series of large number of trials n with P the probability of success at each trial, then the small number is given by a small number, that probability of success at each trial is a small number. Then the probability distribution, that is Poisson distribution, is given by P of R is equal to e raised to minus z into z raised to r upon r factorial. So this is the formula of probability distribution. P of r is equal to e raised to minus z into z raised to r upon r factorial. See that what is z? Z is equal to mean, and the formula for mean is n into p. N is number of trials and p is the probability of success. So this is the formula of mean of Poisson distribution, and that the value z is means the mean is used here in the formula of Poisson distribution, and variance of Poisson distribution, it is given by sigma square. It is equal to n into p into q. When n is number of trials, p is probability of success, and q is probability of failure. Okay, so here is the formula of probability distribution. Mean of Poisson distribution and variance of Poisson distribution. Now the example. A manufacturer of quarter pins knows that 2% of his product is defective. If he sells quarter pins in a boxes of 100 pins and guarantees that not more than 5 pins will be defective in a box, find the approximate probability that a box will fail to meet the guaranteed quality. See, what is the example here? A manufacturer of quarter pins knows that 2% of his product is defective. Means this is the standard probability of the product of manufacturer, that 2% of his product is defective. Okay, means this is your success, probability of success 2%. This is the guarantee of the manufacturer, means standard probability of his product. If he sells quarter pins in a boxes of 100 pins and guarantees that not more than 5 pins will be defective in a box. See, what is the guarantee? If the manufacturer sells quarter pins in a boxes of 100 pins, means suppose the box is of 100 pins and the manufacturer guarantees that not more than 5 pins will be defective in a box. Then find the approximate probability that a box will fail to meet the guaranteed quality. Okay. Now here n is equal to 100. The number of pins in a box is 100, so n is 100. Now p with the probability of defective pins in a box. See, what is the standard probability given by the manufacturer? 2%. Means p is equal to 2% means 2 upon 100. So if we simplify it, the value is 0.02. So this is the probability of success. Means the probability, standard probability given by the manufacturer. And now here the value of n is 100. It is a large value, and p probability is equal to 0.02. It is a very small value. So we are going to use here Poisson distribution. See, in example, only in the example is given in words. Here it is not mentioned that you find the probability by using binomial distribution or Poisson distribution. You have to decide how to find the probability, whether you use Poisson distribution or binomial distribution. But the condition for Poisson distribution is that if the value of n is large and probability is very small value, then in that case we use Poisson distribution. So here the value of P probability distribution is a very small value, 0.02, and n is a very large value, 100. So we are going to use here Poisson distribution. Now to use the Poisson distribution, we want mean of Poisson distribution, and the formula is n into P. The notation for mean is Z. So Z is equal to n into P. So see, what is n number of trials is 100. What is P? Probability is 0.02. Now you calculate the value of Z and it is equal to 2. 100 into 0.02 is 2. So Z is equal to 2. Mean is 2. Since P is very small, probability is very small, so we are using a Poisson distribution. See, what is the formula of Poisson distribution? P of R is equal to e raised to minus Z into Z raised to R upon R factorial. Now you know the value of Z. Z is mean. It is 2, e raised to minus 2, 2 raised to R upon R factorial. After putting the value of Z, 2. Now see, what is our aim? What is the guarantee of the manufacturer? The guarantee, the manufacturer sells quarter pins in a boxes of 100 pins and guarantees that not more than 5 pins will be defective in a box. So first you find the probability of a box not more than 5 pins will be defective. Not more than 5 means the defective pins may be equal to 5 or less than 5. So the condition is probability of R less than or equal to 5. So we are interested in the probability of R less than or equal to 5. R less than or equal to 5 means you start from 0. 0, 1, 2, 3, 4 up to 5. Now we can write this term in the form of summation because we are going to add that 6 term R is equal to, from R is equal to 0 to R is equal to 5. So we can write the term in the form of summation also. Summation e raised to minus Z. This is the simplified term of Poisson distribution. E raised to minus 2 into 2 raised to R upon R factorial. And R varies from 0 to 5 because R is less than or equal to 5. So we are going to start from 0 up to 5. So this is the probability of a box Poisson distribution. Now probability that a box, see what is our aim? This is the guarantee of manufacturer that not more than 5 pins will be defective in a box. Now find the approximate probability that a box will fail to meet the guaranteed quality. We are interested in the probability that the box will fail to meet the guaranteed quality. What is the guarantee? That not more than 5 pins will be defective. This is the guarantee, and we are going to find the probability that the box will fail to meet the guaranteed quality. Means here we are interested in the probability that a box will fail to meet the guaranteed quality. What is the guarantee? This previous step is the guarantee that probability of a box not more than 5 pins will be defective. This is the probability of guarantee. Now the manufacturer failed to meet the guaranteed quality. Means the manufacturer is not satisfying this condition that 5 pins, not more than 5 pins will be defective. So if we are interested in the probability that that manufacturer will fail to meet the guaranteed quality, then it is equal to probability of R greater than 5, strictly greater than 5. So you start from 6, up from 6 to the value of n is 100. So you start from 6 up to 100. So it is not possible to find the probability of every term from 6. R is equal to 6, R is equal to 7, 8, 9, 10 up to 100. So best way, the probability of R greater than 5, it is equal to 1 minus probability of R less than or equal to 5. And probability of R less than or equal to 5 is here in previous step. It is summation e raised to minus 2 into 2 raised to R upon R factorial. R varies from 0 to 5. So you subtract this term from 1 so that you will get that the probability of a box will fail to meet the guaranteed quality. Simplify it. Using calculator, you can simplify the term and calculate the value of every term. That e raised to minus 2 is constant, so you can write outside the summation. R is varying from 0 to 5, 2 raised to R upon R factorial. So it is 1 minus e raised to minus 2 bracket 2 raised to 0 upon 0 factorial plus 2 raised to 1 upon 1 factorial up to 2 raised to 5 upon 5 factorial and so on. So you simplify it, and the probability of r greater than 5 is 0.0165. So this is your answer. The probability that a box will fail to meet the guaranteed quality. This is your answer. Here, the first example is over here. Second example is here. In a certain factory turning out razor blades, there is a small chance of 1 by 500 for any blade to be defective. The blades are supplied in a packet of 10. Use Poisson distribution to calculate the approximate number of packets containing no defective and 2 defective blades in a consignment of 10,000 packets. See, the standard probability of a defective blade is given. It is equal to 1 by 500. So here in solution, we can say here P is equal to 1 by 500. If we calculate the value, it is 0.002. And in a certain factory turning out razor blades, there is a small chance of 1 by 500 for any blade to be defective. The blades are supplied in a packet of 10. It means that the value of n is here 10. Use Poisson distribution to calculate the approximate number of packets containing no defective. No defective means r is equal to 0. So how to calculate? We have to use here Poisson distribution. It is already mentioned in the example. If it is not mentioned, in that case also we will use Poisson distribution, because the value of P is a very small value. It is nearer to 0, 0.002. So in that case, we use Poisson distribution. After finding the value of P and N, now here the mean Z, notation for mean is Z, it is equal to N into P. And so if we do the multiplication, it is equal to 0.02. So because we want this value of mean to find the probability using Poisson distribution. Now the probability of a packet containing no defective blood, because our first aim is you find the probability, use Poisson distribution to calculate the approximate number of packets containing no defective blades and then 2 defective blades. No defective blades means the value of r is equal to 0. Using Poisson distribution, you find the value here. See, no defective means r is equal to 0. Now see, what is the formula of Poisson distribution? E raised to minus z. Z is here 0.02 into z raised to r. Z is here 0.02 raised to r. R is 0. The value of r is 0 upon r factorial. R factorial means 0 factorial. Now simplify this term, and its probability is nothing but 0.9802. 0.9802. And now we want the number of packets containing no defective blades in a consignment of 10,000 packets. So 10,000 into 1 upon e raised to 0.02. Or here you can write the value of this probability 0.9802. If we do the calculation, it is 9802. So these are the number of packets in a consignment of 10,000 packets containing no defective blades. Now, second aim in the same example is that you calculate the approximate number of packets containing 2 defective blades. 2 defective blades means r is equal to 2. Means you find the probability of packet containing 2 defective blades, means r is equal to 2. Again use the Poisson distribution, e raised to minus z, z raised to r upon r factorial. Z is 0.02 and r is 2 factorial. So in denominator the term is 2 factorial. Z raised to r in numerator. Z is 0.02 to the power r. R is 2. So to the power 2. 0.02 to the power 2. Simplify or calculate the value. Using calculator, you will get your answer 0.000196. This is your answer. The probability of a packet containing 2 defective blades. Now we want the number of packets containing 2 defective blades in a consignment of 10,000 packets. So multiply that probability of a packet containing 2 defective blades by 10,000 and simplify it. So it is equal to 1.96. 1.96 means approximately 2. So there are only 2 packets containing 2 defective blades in a consignment of 10,000 packets. So this is the example of Poisson distribution. Here, this session is over. Thank you.